Okay, you guys, this is going to be my PixInsight walkthrough for challenge number 34. And keep in mind now, I am not some kind of master at PixInsight, okay? I just found a series of tools that seem to work really well. And, you know, there's probably all kinds of little things that we can do to, pull out all the little nuances and stuff, but this is sort of the typical Neil's down and dirty 10 steps to a great looking image. So here we have our raw data. It's in the form of this 16-bit TIFF right here, and we're going to open our screen transfer function. I keep the functions that I've been using just right on the main screen here, but so you click this little button right here, the link RGB channels, and then the little, I'm not sure why it has that, it's like a nuclear, radiation button or something. But anyway, so we're going to click that and we get our screen stretched image. And this is one of the things that I just love about PixInsight, is that it automatically manages the clipping. So it's, nothing is overstretched here. But we do have this artifact from the misalignment of Ron's frames. So we're going to crop that out. Under the Process Explorer, I'm going to open this dynamic crop tool. And up here in my little toolbar across the top, make sure that the crop button is selected. And then I'm just going to pull this guy down like that, and push the little green execute button there and get this thing down to size. The script editor decided that it wanted to play. So we're going to push this button right here to make the window fit a little tighter. So, okay, so that's it. We're done with that crop. The next thing that that we're going to do, and I mean, this is kind of, do it or not do it or whatever, but I'm just going to use the resample tool to drop it 50% of its size, because this is just going to be a web display. So 50%, you drag the little instance icon over onto the image, and it crops it like that. You can push this guy to zoom to fit our screen here. So we're done with the resample. The next thing that we're going to do is neutralize the background. You can see that there's a bright gradient towards the top, and there's also some green cast and some other things happening in here. So opening the background neutralization tool, we're going to choose a reference image. Now this reference image needs to be a preview of just the background, and I'll tell you what, this image, hardly any background, full of stars, but there's a little spot right here, for example, that doesn't really have any stars in it. So up in our toolbar, we're going to click on this button right here, the new preview mode, and then we're just going to drag out a little section here and try to avoid some stars. So here we are, preview 01. So our reference image is going to be preview 01. I'm not going to change anything else. I'm just going to drag the triangle onto it, and voila! Isn't that beautiful? It just needs to be re-stretched. The calibration needs re-stretched. So we're going to go back down to our screen transfer function and push the little radiation signal, and it looks like that. So this was what it looked like before, and this is what it looks like after. So it really cleaned it up well. Background neutralization. You can see that it's still brighter at the top of the image than it is at the bottom, and we'll address that in just a minute. But we'll do this color calibration next to try and deal with some of the off color. So in this one, it wants a white reference and a background reference. Now we already have a background reference, which is preview 01, that has a little preview of just the background. And I'm going to choose this star right here, or these couple of stars, for my white reference. So I'm going to go up here and click on this new preview mode and drag a little marquee around this star here. And then select that preview 02 as my white reference. And we'll leave this structure detection because that's actually going to look at the stars. So then we just drag this onto here, and pretty subtle, but you should see a little bit of a color flattening and calibration there. So that's really good. We're done with that guy. The next thing that we're going to do is run the dynamic background extraction, DBE. Now the way that, here, you know what, I'm going to take my previews and delete my previews, reapply the screen stretch. So the way that this dynamic background extraction works is you click on the image. I don't know how it works. Here we go. We click on the image, and then you start placing these little sample points. If you're familiar with PixInsight, you probably are familiar with this tool. But basically, you want to, again, not put it on stars, not put it on structures, just put it on backgrounds predominantly. And so, you know, I'm going down this little dust lane here. I can come up here. I'm trying to avoid stars and whatnot. And the more points that you put on there, the better. So one of the cool things that I really like about PixInsight is that if you take this little triangle and drag it off onto the screen, then you can actually close this, and if you double click this, it'll pick up exactly where you left off. So you can save process instances like this. Now I actually have a process instance already saved for the dynamic background extraction. It has all the little pieces where I want them. And we will actually, the only other thing to note, I didn't change any of this stuff. I just placed my points where I wanted them to be, and under the target image correction, I chose subtraction, normalize, and discard background model because we don't need to keep it, and replace the target image. So this is going to normalize the information. It's going to create the background model mask. It's going to apply it to the image, update the image, and delete the model. So that's basically what that stuff does. So we're just going to push our little green execute, and you'll see that our gradient is gone, and the color is really well balanced still, and it hung on to all of that. So that is the DBE. The next thing that we're going to do is the noise reduction. We want to do the noise reduction before we actually do real manipulation to the data. We have manipulated the data, but only in its nonlinear fashion. Remember, we haven't stretched this data yet. This little icon up here, by the way, is the enable disable screen transfer function, which is this guy down here, which I suppose we could even update it. So anyway, so yeah, the data looks like this still. So before we actually apply all of these stretches and everything, we're going to do the noise reduction. And I've played with several different noise reduction tools in PixInsight, and I really like this Atrus wavelet transform. Traus, I don't know, Atrus. So basically, with 5 layers, and the noise reduction checked, if you set the first one, honestly, I don't exactly understand the math behind this, but I just know that this is how this tool works. If you set the first one to 3, and you set the next one to 2, and you set the next one to 1, and you set the next one to 0, and then you leave the last one blank and leave this the residual layer. Then when we here, I'm gonna make a copy of this. By the way, when your icon is on this little tab right here, your arrow, your cursor, and you hold the Shift key, you can copy it to its own preview. And we can grab some previews like this. So you can click your preview and hit the little zoom to fit button. So now we have a couple of previews that we can work with. So if I set this up 3210, not changing any other parameters, and drag it out here, it'll go through its execution stage, and hopefully you can see that that did a lot of smoothing. I mean, it basically got rid of all the noise. We've got some ring issues here around our stars and whatnot, but the background is like perfectly smooth, but of course that's ridiculous. So you know, we're not doing that. But that just shows you the strength of these particular settings, the 3, 2, 1, and 0. Now again, I have one of these already set up in a little process here, and after some fiddling around with it, I really like the 1.25, 0.75, 0.25, and 0. I'll show you what that looks like on this preview here. Again, no other parameters changed. So you can see that that is much more subtle. Depending on how this video comes across, you know, that might still be artifacts and stuff. I don't know, but anyway, much more subtle. You can see that that was the stronger one. This is the lesser one, and then this is the original image. So you can see that there's a little bit of softening happening. We could have masked this stuff out, but this particular image has a lot of noise through the whole thing, and so I'm just going to go ahead and compromise the image a little bit by softening the entire thing with this noise reduction through the A-Traus wavelet transform. So we applied it to this preview, which we're just going to delete. This one here, which we're just going to delete. So now that we're happy, we've played with our parameters, and we know what we like, then we're going to now apply this to our main image here. And we're done with that one. The next thing that we're going to do is, in order to run this particular saturation procedure, and I don't know, I don't actually know if this is the best saturation procedure or not. It's the only one that I know at the moment, but it works really, really well. And so we're going to use it. But in order to do it, we can't do it on the unstretched data. So we have to apply everything that we've done so far into the actual image. So no more of this screen transfer stuff. We need to really manipulate the data now. And so the way that we're going to do that is we're going to open the Histogram Transformation tool. We're going to check this little checkbox down here to track the view, which puts our histogram information in the windows. And we are going to turn off, well, here, let me grab a fresh screen transfer. So I just push this little, you know, nuclear, we're all going to die button again, and to update the data. But I'm going to turn that off from the view. And what you do is you drag the new instance of the screen transfer onto this bottom bar. You can't put it in the middle. You can't put it in the window. You have to drag it onto this bottom bar. And that is going to update the histogram to what it's actually going to be. And then we are going to apply that to this image. So now this image, without the screen transfer anymore, that's the real deal data. So we just applied all of those changes to our data. Alright, so we're done with the histogram transformation. So here's this really cool trick that I learned for saturation. With the image selected, and you go into the image menu, and under extract we basically pull out the luminance frame. So now we have a luminance image here. Going back to, we're not going to manipulate the luminance data or anything, but going back to the original data, we're actually going to use an LRGB combine process. We're not going to be doing red, green, or blue because we've already got that. But what we're going to do is pull in this luminance frame here, and I'll show you this by using another preview. In fact, let's do a couple of them. Let's get both of those set up. Okay, so with this LRGB combination process, one of the functions in the transfer function is the saturation. If we, using this luminance, pull the data into this and recombine them, it basically doesn't do anything because we haven't changed anything. But if we change our saturation from 0.5 to, let's just say, point, whatever, 2.5, and we do it again, hopefully you can see this on the video, we just gained quite a bit of saturation in there. In fact, enough to where we can push it even a little bit more. So we'll open this one, and I'll go 0.20 and drag this one over here. So that's even more saturated, but it looks really great. The golden dusty stuff in all the stars, the red, I don't know, there's some emission nebulas and some reflection nebulas and stuff in here. And you can see from preview 2 a little bit less saturated than preview 1, and of course both of them significantly more saturated than this. Now inside of this, the dark area in particular, hopefully you can see this on the video, there's lots of splotchy reds and greens and blues and stuff. There's just a lot of chromatic noise in there. And this tool not only will do the saturation, but it also knocks out the chrominance noise. So if I click, not only leaving this at 0.2, but turn on the chrominance noise reduction, not changing any parameters, just checking the box, it takes an extra second here to do that. If I zoom in on that same area now, hopefully you can see this on the video, there's no chrominance noise in here. So that's why I really like this LRGB combine, because we can get our saturation and get our chrominance noise knocked out both at the same time. So I'm going to delete this preview, and apply this to our image. So now that that's our image, we're done with this luminance frame. We don't need that anymore. And I mean, look at how great this is. We've only done a few steps here, not tweaking all kinds of parameters. Granted, if we made masks and stuff, whatever, things might be better or whatever. But I mean, this is really, really amazing for only a few steps. So the last step that we're going to do, well, maybe not the last, but the last sort of major step that we're going to do is address the contrast a little bit. And we're going to do that using this HDR multi-scale transform. Now, one of the things that I know about this tool is that the here, let's do this again. So we'll grab a couple of previews here so you can see. So at 6 layers, the higher number of layers, the more aggressive the effect is. So I like this Lightness Mask, using this Lightness Mask, which takes care of basically trying to adjust the areas that are too light or too dark. And then this to lightness basically says which part of the image, what of the color is going to be worked on. And I suppose we should probably check this de-ringing, because this is a This is like a, I don't know, it's a wavelet or something, and so it'll like mess with the stars and whatnot, put some rings around them. So anyway, with this preview 2, with this number of layers 6, we'll drag this guy onto here and see what it does. Okay, so that's what that does at 6 layers. We'll drop it down to, I don't know, 3, and with all that same stuff, we'll apply it to this one. So here's 6, and here's 3. You can see that 6 has the stars a little bit brighter. 3 has the stars a little bit dimmer. It's not quite as aggressive. So the higher number this layers is, the more aggressive the effect. And you can especially see, like right here, this nebula is fairly bright, and the little dark areas inside of it are still fairly gray. And on this one, the whole thing is kind of dimmed down a little bit. So let's look at 4 on this, and see how that does. All right, so 4. I don't know if you noticed that it darkened in these lanes a little bit. Here, look at it from this to this. You see that? So still a little less aggressive than 2. So we're gonna get rid of preview 2, which was 6 layers, and I kind of like this 4 layers. So we're going to delete that one, and we're going to apply this 4 layer to this one. Okay, so now we have really nice contrast. You know, our noise is already dealt with. Our stretching is already dealt with. You know, that's basically it. The image still almost seems a little bit light at the top, and we could just pop open our background extraction process again and just run it again and see if that kind of cleans that up a little bit. So this was it before. This was after running a second iteration of that. And really, now that I look at that, I really think that the second iteration is helping get rid of the washed out sort of look at the top and balancing the image a little bit better. So we'll leave that. Now you notice that I didn't even do a curve. I do have my curves open here. We can click our little track view button and click on the RGB, and we have to click this little guy, the real-time preview. We could, you know, make some nonlinear curve adjustments if we wanted to. You know, that's not so bad. Maybe add a touch of contrast or pull that top nebulosity out just a little bit. So I don't know. Let's just say that we wanted to do that. Then, you know, you could do that too. So anyway, that's it, man. I mean, super easy. It looks fantastic. You know, if I zoom in on the image, I don't know. I guess it's this way. You know, even large, it still looks pretty good, especially considering how much noise was in this image. Now, you know, you could add some star masks and stuff in there to keep some of those brighter Milky Way stars a little more under control if you wanted to. I kind of like the stars being a little bit large with the really dusty ones behind them and the larger ones in front of them. To me, that kind of gives a three-dimensional sort of layered you know, look to the sky myself. So I kind of like that. I don't necessarily like the itty-bitty tiny little stars, but you know, to each his own. That's one of the things that's so great about, you know, processing is it's sort of subjective in that way. But anyway, so that's my quickie little 10 steps to a really amazing process of a great image. We didn't push any colors. This is all very natural. This is just straight stretch data without you know, manipulating the blues or the reds. You know, we could probably do that as well if we wanted to. But yeah, so anyway, there you go. I hope you enjoyed it. I hope you learned something, and thanks for watching.